Hi everyone, my name is Dwayne Davis. I'm a doctoral student at the New Jersey City University. Today you're going to learn how to run an ANOVA, an analysis of variance of three or more groups that have been treated um, with some um, difference and will be measured for the same output. So an analysis of variance does just that. It takes three or more groups and with each group being treated separately to test for variability for a similar output or result. So let's get started. Um, the example that I have here are is made up of three groups. And so the first group is an action movie. The second group is an animation movie. The third group is a comedy movie. And 29 individuals went and watched these movies. So that is the treatment. We have the same individuals, and the treatment is watching a different movie. And what we want to see is whether or not the output of the ratings differ based on the movies that are watched. Um, this isn't the most practical example, but it will give us the idea of how ANOVA is used. So we're actually looking to analyze whether or not the variance in the data variance in the data sets are actually different. So the ANOVA test will test the hypothesis, the null hypothesis of there is no difference in the variance or the mean of group A, group B, and group C. The alternative hypothesis is that there is a difference in variance of group A, group B, and group C. So let's start. We're going to use Stats Plus for this example. If you have the Excel 2011 like I do, you will notice that there isn't a built-in statistical analysis tool or plugin, so you'll have to use Stats Plus. Stats Plus is very similar to SPSS or the built-in statistical analysis tool in later versions of Excel. This will be beneficial for you to learn. So in order to get Stats Plus, you'll need to download it. So you'll go to Google and you can type in Stats Plus for Mac. The first link will pop up and you download it, run the application, and then you are ready to go. So here I've already done that. So I'm going to go ahead and open up Stats Plus. I'm going to grab my data sets, copy them, and I'm going to paste them in Stats Plus. Pretty straightforward and intuitive. So now I have my three sets of data that I want to analyze for differences in variance. And I'm going to use the ANOVA, the analysis of variance test. So I'm going to click on ANOVA, and I'm going to do a one-way ANOVA test. And so I'm going to see in the left column here my data sets that I want to compare and analyze. So I'm going to click on, in order for me to pull them over, I'm going to click on each data set and then enter them one at a time. There we go. I want to check my preferences to make sure that I have my confidence interval set to a standard level of 5%. So I'm good to go there. And I also want to check that labels in first row is checked off so that that's not a part of my calculation. If not, I'll get errors. And I'm going to click OK. And literally, that's it for the ANOVA test. The results, it created a results page which gives me my sample size. So there were 29 observations for three groups that were treated. I get the sums, the mean, and the variance, for each group, and also then I get very important standard ANOVA statistics. I have my degrees of freedom for between, and I have my degrees of freedom within. I have my sums of squares, and I also have my F value, P value, and F critical. What I'm looking for here is to find significant differences in variance. I'm looking for an F value that's greater than my F critical value. In this instance, you can see that I have 3.98360 compared to 3.10516, which tells me that I can reject my null hypothesis that there is no change or there is no difference in variance between the three groups. Also, I see that my level of significance is high because I have a p-value of 0.02224, which is lower than a p-value of 0.05. Given this information, I know that there is significant differences in the variance of my data sets. But what I don't know is which data set is actually different. So now I'll actually have to run a post hoc test to figure that out, and I will do that.